I had a quick question about the homework, just about like D, E, and F. You say use the Cartesian representation. What do you mean by the Cartesian representation? What does that mean?
Yeah, so uh, I can dig them up, but you can always represent complex numbers in two ways. And they're very useful, both of them. So, we did it here. So Cartesian way means you're in a square grid and you're looking at X and Y. So Cartesian way is you think of a real and imaginary part and you plot it in Cartesian square grid. This is X and this is Y, and it's a point in a Cartesian representation as a pair of numbers. The polar representation is you sit at the origin, you measure the distance to the point, and you measure the angle from the point. So you can do Cartesian or you can do polar. And when you solve problems in complex analysis, you keep going from one to the other. So sometimes when you're looking at neighborhoods, it's natural to look at a little circle around the point you're interested in. So it's natural to represent a neighborhood by how far is the border of the neighborhood and at what angle is a point on the neighborhood. So polar is very good. When you're taking partial derivatives, it's often easier to do it in Cartesian way, in X and Y direction. You can do it also in polar coordinates, just uglier, as you know, from electromagnetism, etc. In quantum mechanics, we sometimes write formulas for derivatives in other coordinate system other than Cartesian.
If you don't specify which representation, is it okay if we use polar or can we write it as R e to the I phi or?
My attitude is that all is fair in love and war. So in physics, there are two things. In research, doesn't matter how you got the result. It's totally personal. Now, when you communicate to other people, you want to use the language that they're used to. So even though you had a very beautiful, intuitive way of discovering that, graphene behaves like Dirac electron or something, then you rewrite it in either Cartesian or polar, whichever makes it easier for your, graduate student colleague to understand your answer. So, I don't care how you do it. It's very personal. Some people solve problems by drawing pictures. Other ones do very complicated calculations. It doesn't.
Professor,
I've experienced this in my own research, which is I worked at the Institute. I was postdoc at the Institute for Advanced Study, which has, exceptional people in. So I worked with a man who can do infinitely tedious calculations without any errors, which was good enough to make him professor at the Institute for Advanced Study in Princeton. But, it's so boring what he does. So his collaborator, I would, finally understood what he did. I would translate it. I would make it into a simpler thing. But it didn't matter because he solved the problem and I was just a guy who, made it popular. So a tank might work in a way that's totally incomprehensible to you as a human, but it's a tank and you respect it. Book does everything I do. I don't do anything that's not in a book. I just, give it a different angle. So there's nothing that I've done that's not in the Arfken, Weber, and Harris.
Okay, that's fine.
I'll think about this.
That's fine.
The point is, I have to explain what the problem is this. every bird knows how to sing the song. You know, it's part of our education of everybody in engineering physics. We all have to learn complex analysis. It's been done beautifully by people much smarter than myself. So then, you know, I write some kind of ugly little notes. I scribbled them. So why should I subject you to my ugly little scribblings? But you can read, you know, well-reasoned, beautiful argument that derives it, and then you read it and say, "Oh, I see. So that's what Predrag did. You know, he did it in some kind of." So that's why I'm reluctant to write too many notes on something that's done so much better than I can ever hope to do it. Or, you know, there's no reason for me. I mean, I'm paid to do things not yet done. This has been done very well. It's middle of 19th century. Yeah. So this my notes are, but I've given you, actually, I like on the homepage, Professor Grigoriev, Roman Grigoriev, my colleague, who sometimes teaches this course, he has very nice notes and they're very compact. So see whether you like his notes. I mean, they're kind of, you know, condensed and sensible handwritten notes. So check those out. They cover this material.